All right, everybody, today we're going to go over the helicoil tapping arm. I'm going to show you guys a demonstration and a little bit about what makes this arm such a great unit. We'll start with the assembled arm here. So you'll see we have our 1500 RPM helicoil motor, our filter lubricator with the built-in regulator. That way I can dial my PSI for my front end assembly depending on the size helicoil that I'm going to be running. So you'll see these arms are nicely equipped with a roll that we can put right on the arm, and we put the helicoils in a strip feed here so that we can do fast, easy helicoil insertion for any of your thread repair. All right, so starting with the motor, you'll see this is the helicoil motor, 1500 RPM motor that we use for driving the helicoils. Each motor comes with a small adapter, or a large adapter, or a small adapter. So these adapters are used as bridges for different sizes of front end assemblies. So in this case, for the large, or for the small adapter, we're going anywhere from, this is for the 256 to 1/4 inch front end assembly. And then this is our large adapter for 5/16 to 1/2 inch. And this adapter goes onto the motor, and this is what is used to bridge the motor and the front end assembly. Everything's left-handed thread, so we put that on, and now the motor's ready to receive a front end assembly. The other component I'll show you, it's a friction clutch. So the friction clutch is used for our small adapter for your small helicoils. So anything from 256 to 440 is what I'm going to use or recommend the friction clutch for. In the small adapter, we pull out the stock insert and we put in the friction clutch, and this is just really going to help us with those smaller holes to limit the torque and stop us from damaging our front end assembly or the threads that we're repairing. So next you'll see this is an example of a front end assembly. This is a 3/8 16 front end assembly. This is our nozzle, this is the mandrel, and each one comes with a bag of cushions and spacers. So we use the cushion goes into the large adapter, and it helps cushion your mandrel, your driver, and then different spacers here for setting my depth. So that way, another advantage with the arm is you can set the depth, so that way I can drive the helicoil to the proper depth every single time. And I'm setting that here with these spacers, and I'm putting it on my mandrel. So I'll put one of these on here as an example. And we would place one of our cushions inside the large adapter here. And we place the front assembly on. And again, left-handed threads, and that's about it. So now we're ready. So today, what I'll show you, I've got my arm set up here to drive quarter 20 helicoils on this strip feed, and we've got a nice aluminum piece here ready to place those. This is a blind hole. We're going to drive them to the bottom. Depth's already set. Automatically revert. So it automatically drives it to the depth and then automatically reverses. So you'll hear the motor has a hissing. That's normal. It's designed that way. First things first, I'm going to set my pressure here. So something to note is every front end assembly has a desired PSI to set your air pressure correctly for the helicoil. So in this case, it's set for 45 PSI. So I'm going to take my regulator, I'm going to adjust my pressure, set it to 45, lock it in, and now we're ready to drive the helicoil. So I have everything set up here on a strip feed knob. So I'm just going to simply line the arm up over the hole. I'm not going to fight it. I'm going to let it do the work. So we'll drive it on down. Automatically reverse. Now we have a perfectly placed helicoil. And that's all I have for today. If you need more information on our helicoil FlexArm, give us a call or shoot us an email. You can visit our website at flexmachinetools.com or 800-837-2503, and we look forward to helping you out with your next thread repair job. Thank you.
You like what you see? Now what if I told you you didn't have to own a FlexArm to enjoy one of our carts or tables? Now, even though they're primarily made for tapping, let's see what else they can do. You can also use it as a mobile workbench. The 200 tapped holes make fixturing a breeze. You can use it to haul raw materials. You can use it to haul finished parts. Use it at your next cocktail party. Use it for an arm wrestling table. You can even use it to haul your trash and recycling. Really? And with a weight capacity of up to 1,000 pounds, you can haul whatever your heart desires. Need a place to put your TV? FlexArm mobile cart. Need a dining table for your date night in?
Wait, this isn't a table?
FlexArm mobile cart. Trying to hide from your pesky boss? FlexArm mobile cart. And they're so durable, you'll even be able to pass it off to your grandson. And just in case you need something a little bigger than our mobile carts, check out our line of coolant troughs and tables that are just as versatile.
Hey guys, it's Tyler here from FlexArm. We recently had a prospect reach out to us looking for a better tapping solution. National Enclosure Company out of Michigan is a nationally ranked advanced facade contractor, and they were looking for an efficient way to tap the end of an aluminum extrusion. They're currently outsourcing these parts or tapping them in-house with a hand drill. The problem with outsourcing is that they have no control over the quality or consistency of their parts, and their volume is way too high to continue the slow process of tapping with a hand drill. I told them to send some parts in and we could run a tap test on the FlexArm. The extrusion needs 2 inches of total thread depth and needs to accept a set screw in the end, so we fixtured the part horizontally and decided to go with the GHM18 hydraulic unit. This has the multi-positional head which will allow the operator to tap horizontally and easily reach their desired thread depth. One issue that we ran into in this tap test was chip evacuation. The end user supplied us with a straight flute pulley tap, but due to this horizontal positioning, the chips had nowhere to go. We swapped the tap with a 3-flute spiral point tap, which helped us pull the chips out of the part. The tap test was a success, and the FlexArm had no problem tapping the part to the correct depth. So if you're experiencing any similar problems or just looking for a better way to speed up your tapping process, go ahead and give us a call at 1-800-837-2503.
What's up, everybody? This is Eddie, and we are coming at you live from FlexArm's beautiful facility right here in Wapak, Ohio for yet another amazing demonstration. Today, we're gonna be doing some blind hole tapping, and I'm not talking about putting on a blindfold and tapping holes. We're gonna show you the tips, tricks, and techniques behind doing this efficiently as well as properly. But before we get started, huge shout out to our great friends and partners over at CNC Cookbook. Make sure you check them out after the stream. We thank you so much for your participation and your partnership. And then so with that as well, we're gonna have a contest today. We're gonna be giving away a $100 OSG tap voucher. And for the way that you can enter in, you'll notice on this side of the screen, there is a comment section. On the top of that comment section, you'll notice there's a registration link. I highly encourage, if you'd like to enter into this contest, hit that registration link, put in the necessary info, and you will be entered in the contest to win, and we'll be picking that winner at the end of this live stream. And speaking of that comment section, with this being a live and interactive stream, we highly encourage and anticipate each and every one of you to put any questions or comments that you may have right there in that chat section, and you never know, we may be able to pull those bad boys up and answer them in real time. Also, you notice on this part of the screen there is a subscribe button. Make sure you hit that subscribe button, you hit that bell so we can keep you in the loop with all the amazing content notifications. And last but certainly not least, give us a huge thumbs up. So when it comes to blind hole tapping, I got my expert in-house man, TA. So TA, a lot of people are afraid of blind hole tapping. Why is that?
Yeah, Eddie, thanks for inviting me out today. So to answer your question, the reason why a lot of folks either don't get into tapping in their shop, or they don't really get into tapping, is one, they don't necessarily have an efficient way of doing so, so that restricts the machine shops and fabricators from bidding on their job. So tapping is typically one of the last processes at the end of a machining cycle. So guys typically don't like to go towards it because one, it's a pesky tap, and with it being the last operation, the operators have the fear of snapping that tap off. And when doing so, snapping that tap off, you're not only breaking the tool, you're scrapping the part, you're wasting material, or you're having to rework that tap out of the part for anywhere from 30 minutes to 60 minutes. And then lastly, at the end of the day, businesses are making money, and if you're snapping taps off your parts, that's certainly holding you back from achieving that goal. No,
absolutely solid, man. That's definitely why you're here for the expert. I dig. So hey, man, right off the rip, let's hit him with some blind hole tapping on a hydraulic unit. What do you say, man?
Yeah, let's go ahead and
let's do it.
We'll dive into that.
There you go. So what are we looking at? What are we doing first?
Yeah, so for the GH24 model, this is one of our hydraulic units. So we're going to be able to tap anywhere from a 632 up to 3/4. So we'll go ahead and get the power pack set up here.
There we go. There we go.
So this is our hydraulic unit, the GH24 tapping arm. So we'll go ahead and fire it up real quick. The first tap that we're going to run is going to be a 1/2 inch tap, blind hole, 1018 mild steel. So we're going to go ahead and put the tool into the FlexArm. The kind of tap that we're using today is an OSG, oh so good, 3-flute bottoming tap. So we're going to go ahead and just articulate the tap over the part. For this demonstration, we're going to run the tap at approximately 300 RPM. So once we have that dialed in on our power pack, we'll go ahead and articulate the tap over the part. So the FlexArm is going to self-align that tap. So you see here how the OSG tap evacuates that chip out. That way the cutting teeth can continue to make the threads into the hole. And then we are now at the bottom of the material. So this is about a 3/4 inch mild steel tapping plate that we use for demos. And you can see, we know that we've reached the bottom of the hole because our torque holder is ratcheting out. That's a safety mechanism that's going to help us eliminate tap breakage in the part. So we'll go ahead and back that out real quick.
Right on. Hey, that was a good thing to be able to start with, man.
Go ahead and run one more for you just so you can see that again.
There you go. Looks efficient, man. Looks efficient. So hey, before we're going to be obviously doing a little bit of hydraulic, we're going to switch to pneumatic. But before we get rolling, I'd like to have a word from our man Bob at CNC Cookbook. Isaac, if you can pull up that B-roll, we'd love to talk about the importance of the hole size when blind tapping.
Our first tip is to choose the best hole size for your tap. And it's also the tip that's going to make the biggest difference for you. Look, the recommended hole size found on the tap's packaging or in your drill index is probably not the best size. You have to realize there is no one drill size for a tap. Different drill sizes result in different thread percentages. This is what's key. 100% thread is only 5% stronger than a 75% thread, but it requires 3 times the torque to tap it. So for just a little bit stronger thread, you wind up with a much greater chance of breaking your tap. The chart on this page shows that relationship. Those red-orange dots are tapping torque. Look how fast they climb when thread percentage gets above 60%. Meanwhile, the blue dots are thread strength. That curve flattens out just when the torque starts climbing. Those recommended drill sizes on the tap packaging are almost always for a 75% thread. Great strength, but way into that too much torque zone. Okay, let's talk about how to calculate your thread percentages to do that. It's easy. The formulas are right on the slide. You can use those formulas, or you can use a handy chart like the one I show here on the right that my G-Wizard Machinist calculator produces for.
Awesome information, and thank you so much again from our good friends from CNC Cookbook for that quality info. So as we move back into the demo, TA, we're over here at this pneumatic unit. What's going on? Lead the way, man. What are we looking at here?
Yeah, so here we're going to go ahead and thread some different materials. We got about a 2-inch thick aluminum block. We're going to we're going to tap some half 13 threads in. We got some stainless steel. We're going to be hitting some 1/4 20s. And we got some 10 and 18 mild steel. We're going to finish it up with some 3/8. So I think I was having some technical difficulties earlier. So the question was brought up originally. So like, you know, again, why are guys afraid of tapping, or what kind of troubles do they overcome if they don't have a very good way of threading holes? So again, just to cycle back real quick, a lot of our folks out there are currently still doing things the old way. So either tapping by hand in a drill press, and or you know, even in the VMC if they don't have rigid tapping. So a lot of guys don't really get into tapping because, one, they don't really have a good way, and they have the insecurity of breaking the tap. So tapping is normally the last operation in a CNC cycle. So after you spent all the time in the machine and then you take that part offline to tap, or even try to tap, you know, a small 632 hole in the machine, the operator always has that slight fear of you know, bottoming out in the hole, snapping the tap off. And when doing that, you're scrapping the part, you're breaking the tool, you're wasting time, material, and at today, you're essentially throwing away money. So we're going to show you some of the benefits of offline tapping systems and how we can help folks like you eliminate that tap breakage in the blind hole, and hopefully give you the opportunity to bid on more jobs to help build more revenue for your company. So sorry about that. I don't think my mic was on, but I just wanted to circle back and revisit that question earlier. So we'll go ahead and jump into the demo. So again, we got a 2-inch thick aluminum block. We're going to be threading a half 13 tap. Again, OSG 3 flute bottoming tap. So
now, Thierry, while you're getting this set up, I'm seeing you have an array of taps over here. So why is tap selection so important, specifically when we're going into blind holes?
Yeah, absolutely. So one thing that is super critical when tapping blind holes, we need to evacuate that chip out of the hole. So the reason that we're using the OSG 3 flute taps is because the teeth are cutting and it's evacuating that chip out of the hole. Now, if we're doing like a through hole, we would use something similar to this guy down here. So this is what we call a spiral flute tap. So what this tap does is that it pushes the chip down. So what that does is it clears the way for the next cutting tooth to make a revolution and cut that thread. So that's the importance of when you're tapping blind holes, you want to evacuate that chip out of the hole. And then like for through holes, you do something similar to this, which is going to push the chip through. Yeah. Ultimately, you know, leading to, you know, less tap breakage, because that chip's clearing the way. It's allowing that next sharp tooth to come around and continue making a nice thread in the part.
No, great points, man. Let's see what this bad boy can do.
Yeah, we'll go ahead and thread this half 13 tap. Again, it's aluminum. So we'll go ahead and articulate the tap over the part. So as you saw there, we got a clutch mechanism in our tool holder. So once the tap reaches the bottom of the blind hole, it clutches out before the tap breaks. So that's a super nice feature of this kind of an offline tapping solution. It gives that operator the peace of mind that they can just align the tap over the part and allow the arm to maintain the perpendicularity, and then secondly, eliminate the fear or the risk of breaking the tap.
No, very good. Very obviously, we plowed through that. So what's the next size that we're going to be working with today, TA?
Yeah, we're going to go ahead and switch out from the aluminum block. We're going to be tapping some 1/4-20s and some 304 stainless steel.
Very good here. And while you're pulling that up, let's get a little close up here on our HD cam of some of the threads being created from these taps. Very clean here. You like what you see here on the big screen, TA?
Yeah, that looks good for my house, Eddie.
There we go. Good work, good work. Wonderful. Good deal. So just to make sure that everybody at home listens, so what material is this again, and what size hole are we tapping?
The next part that we're going to go ahead and fixture in, the Kurt vise, this is a 304 stainless steel. The threads that we're going to put into the hole, it's a 1/4-20. Again, we're using the OSG 3-flute bottoming tap. We have a lot of luck with these guys here in our shop. It evacuates the chip out real nice for us. Go ahead and just put some coolant there at the end of the tap. And then again, you just articulate the tap over the part. So yeah, stainless steel, 1/4-20 tap, in and out in a couple seconds, 0 tap breakage, straight threads. What more can you ask for at the end of the day, right?
Yeah, well, I've actually heard in some of these tougher materials, especially when you go on blind holes, I'm not too familiar, but it's Peck tapping. I'm sure it's something you've heard of before, so what can you tell us about Peck tapping and why would somebody use it in this type of application?
Yeah, so Peck tapping is basically designed to help break that chip off. As the chips are coming out of the hole, it basically cuts that strand off so that the next tooth can continue cutting. So with the FlexArm, typically you can go ahead and just rip right through. But if you're going through maybe a thicker part where you like to break that chip off real quick, you can just reverse the motor real quick on the unit. It'll break that chip off. That way the strands or the chip is not going to interfere with the cutting tooth of the tap. And again, it's going to help eliminate any kind of tap breakage in the part.
No, very good. And then Isaac, do we have any B-roll on small blind hole tapping here while TA gets that 3/8-16 in steel set up? Here we go. So what are we seeing here, TA?
Oh yeah, that's a really nice video of one of the pneumatic units. That's a 632 tap, tapping into some mild steel. That's 1018 mild steel. I had a client down in Tennessee who's having issues tapping 632s, 832s, and 1032s, and he just wasn't really sure if we'd have the ability to cut these threads. So I was like, hey man, if it would make you more comfortable, let's go ahead and run a quick test for you. The smaller stuff is typically 80 to 90% of what guys are having headaches with. The small 1032s, quarters, and it doesn't have to be that way as long as you have the right solution. You got the torque settings. You got the torque settings set correctly in your tapping arm. You should be able to go at least 3,000 plus holes without breaking the tap, assuming that you're properly lubricating your tap to prolong the life, and again that the torque is set for the right material that you're working with.
Yeah, man, it's got to be scary when you're going into some of those smaller sizes, exceptionally blind hole. I mean, I'm sure there's a lot of operators that you heard from that are just breaking taps left and right.
Yeah, absolutely. I mean, of course not with the FlexArm, but like the other ways that guys are still tapping. For example, they're still using the DeWalt and Milwaukee hand drills. Well, the issue that guys have with that is one that you can't guarantee that you're going to maintain perfect perpendicularity. So with the FlexArm, you can articulate the arm anywhere over the part and you're going to stay at that 90 degrees. So we send the arms out plus minus within 2 thousandths of perpendicularity. And then if they're not if they're not using like a FlexArm, the other option that I see a lot of folks using is that they'll go ahead and start the thread in the VMC. They'll thread about 2 or 3 threads down. That way they can keep the tap straight, and they'll come out and tap it by hand. But then at that point, you're using 2 operations, what could simply be 1. So a lot of guys have the fear of breaking that tap. Again, they don't want to scrap a part. Customers' lead times that need to be met. So if you're scrapping parts, you're pushing that lead time back even further. Right. So again, the FlexArm with the clutch holder or the tap holders, awesome solution to help eliminate any kind of tap breakage or scrap parts.
No, sounds like it. So we've got not 1 but 2, we got 3 examples here. So what's this third block we're looking at?
Yep, so our last example, Eddie, we're gonna run a 3/8/16 3-flute OSG tap. This is 1018 mild steel. So we'll go ahead and chuck the tap holder with our quick change collets right into the spindle. And before I go ahead and rip this one too, another common practice where guys are snapping taps off too, definitely comes like down to fixturing. So like here we got the 2 parallels in the Kurt vise. My arms mount on the same surface as the part that we're going into. So that is another thing, you know, why guys are breaking taps in blind holes. If your part is not perpendicular to the tap, you know, you could run into crooked threads, or, you know, if you're chasing the part, you could cross thread it or things like that. So fixturing is another thing that you want to keep in mind before running the tap to the part. You want to make sure that your workpiece is nice and level for you.
No, makes sense, man, makes sense. Let's see this bad boy in action.
So right there you can see the 3/8 tap made it all the way to the bottom successfully. Made some nice threads for us.
Good deal.
Again,
Let's take a good look at that tap, you don't mind, T. Let's get that on the HD cam here.
Yeah, absolutely.
See, we'll work with all kinds of different things today. There we go. Very interesting. Now, TA, I noticed that this is a little bit different from one of the taps we had seen before, where the bottom of this is flat. So is there a purpose to that, or is there any added value as to why it's flat there?
Yeah, so that is what's called a bottoming tap. So it's designed to reach the bottom of the hole. So with through holes, it's okay to have that spiral point because the tip of the tap is going to surpass the bottom of the hole. So it's just another way that the tap is designed to help evacuate that chip out of the hole. So that flat surface is designed for bottoming holes. That way when it hits the bottom, it's going to help eliminate that tap breakage.
There you go, there you go. Well, obviously we've seen 3 amazing examples on our pneumatic unit. So Tia, we're over here on the hydraulic, man. I want to see a little bit more. We got a little bit of a teaser there in the beginning, but let's feed us. What are we starting off with?
Yeah, so the next thing that we're going to showcase here, Eddie, this is our 3/4 10 tap, just to showcase, you know, whether you're getting into the smaller stuff or the slightly, the larger stuff, there are definitely solutions out there to help eliminate that tap breakage in your parts. So what we're gonna showcase here, again, 3-flute OSG tap, blind hole, mild steel. We're gonna go ahead and run this at about let's be about 200 RPM on this guy, just to show the example of the larger tap sizes. So again, we'll just articulate the tap over the part. Maybe we'll get some coolant on that one real quick, get some of those chips off.
There we go.
So even though we already started that thread, we're gonna go back in and we'll chase the first couple threads and get to the bottom of that hole. Go ahead and move up that tap.
There we go.
Slow her down a little bit. So when that happens with the arm, it could be a setting in the torque holder where I might need to tighten that up a little bit, which could be a reason on why it wasn't going all the way through there. Let's try one more time. But Yeah, Eddie, is there any other questions that we had in regards to the blind hole tapping demonstration?
Well, I mean, with that, so I feel like it's, I mean, you have tap holders for each one of these, so how important is it to have a solid holder, especially when you're doing blind holes of this size and this material?
Yeah, absolutely. I mean, it's super important. So based on the material that you're going through, that clutch is what's going to eliminate the tap breakage in the part. So if that clutch isn't set correctly, you know, you're going to run into the risk of snapping that tap off. And I mean, the series of events that comes after snapping a tap off from the part, again, time, money, tooling, and materials, at the end of the day, you know, if you're spending X amount of dollars on taps per day, well, imagine that over the course of a month. And if you can find the solution to eliminate that, again, it's going to open up the doors to quote more jobs and help your shop work more efficiently and save a bunch of time.
No, awesome, man. So, I mean, with that, before we move to the question and answer section, what is maybe one last thing that all the viewers need to know and all the fans of CNC Cookbook about blind hole tapping?
Yeah, I mean, blind hole tapping, it's definitely a pesky task. A lot of folks don't like doing it. Whether it is you're going through tough materials, you're using the big old T-handles, you're snapping taps. The thing is, at the end of the day, there are efficient ways of overcoming these obstacles. So it's just getting the right equipment and the right tooling paired up in your shop. You guys over here at Flex Machine Tools can definitely help you out and get you kitted up with an arm to meet 80 to 100% of your tapping needs. And I mean, at the end of the day, go back and think to yourself, you know, why don't I bid on jobs that require tapping? 9 times out of 10, it's I just don't have a efficient way of doing so. You know, tapping is it's fearful, it's hard, it's the last step in the process. It's a good way to scrap parts. Whatever the reason is, at the end of the day, just know that there are solutions out there, and we're here to help provide that solution for you. Again, to help you guys generate revenue and take your business to the next level and help you guys deliver parts to your customers, not only in a nice quality thread, but in a timely fashion as well.
No, great stuff, great stuff. So hey, with that being said, Isaac, do we have any questions from anyone in the audience that we'd like to pull up to answer? All right, my man, Logan Skelly. Does the holder come with the clutch already set, or does it need adjusted, Tyler?
Yeah, that's a good question. So here at FlexArm, we send out the tap holders rated for a mild steel. So the way that you adjust the settings, by the way, Eddie, can I have that spanner wrench, please?
Yes, sir.
So the
If I can get it out
adjustable
here, man,
clutch, that is all in the tap holder. It has nothing to do with the FlexArm. The FlexArm's going to help you maintain perpendicularity. So to get our tap out, we'll just press down the press release collar. That releases the tap. And then on the tap holder, there's actually a retaining ring that goes around the tap here. Can you see that? So there's a retaining ring on there that locks the setting in. So you snap off this retaining ring, and then you can see on the face of the tap holder, there's all of these different slots. What these slots are different settings to where you can either tighten or loosen that setting depending on the material that you're going through. So if I have a job in the morning where I'm running mild steel, I'll go ahead and run it, and then at the end of the day I need to switch over to stainless. I'm just going to pop off this retaining ring here, and then I'm going to tighten the setting to the right, and what that's doing internally is just tightening a tension compression spring in there. That way we'll be able to achieve tapping into harder materials. And there's a small little spanner wrench that will go ahead and put in the tap holder. We'll turn that to the right to tighten it. We'll make the adjustment to the left if we're going into plastics or aluminum. And then we use that retaining ring around the collet to lock that setting in. That way we're going to get the consistency in the material every single time.
That's a great question, great question. Isaac, what else do we have from anyone in our viewer section? Chris Garrett. Hey Chris, thanks for joining us, man. Can you use form taps? TA, can Chris use form taps?
Chris, thanks for the question. So to answer, yes, we can use form taps. At the end of the day, it honestly comes down to the end user's preference on whether or not they want to use a form tap or a cutting tap. I typically like to use the form tap, and the reason being is that it's cleaner. It displaces the threads rather than cuts it. So at the end of the day, you get less mess and chips and things like that. We can help you qualify the right solution based on the material that you're going through and the size that you're running. So since we're displacing the material and not cutting the material, the FlexArm requires a little bit more torque. So that's something that we can talk more about if you have an opportunity where you're threading some holes and you want for us to test something out for you. But yeah, to answer your question, form taps, well, you're not going to use an NPT tap in a blind hole, obviously. But at the end of the day, what it comes down to is the square end shank of the tap and then the round shank. So as long as we know the square end shank and the round shank of the tap, we'll go ahead and kit it up into the tap holder. Typically throughout the market, tap square end shanks and round shanks are typically plus minus a couple thou, and then from there we'll help you determine on how much torque you need to turn that roll forming tap. I hope that answered your question. Thanks for reaching out.
Yeah, great stuff, great stuff. What other great questions do we have today? No more questions? Well, that's awesome. Hey, those are still 2 solid questions. So thank both of you, Logan and Chris as well, for submitting those questions. And if we could, who is our winner of our OSG giveaway? Today's live, Chris Garrett, look at that, posed a question, my man. So congratulations, Chris. Obviously you have your information in the registration, but just to make sure, feel free to send us an email at info@flexmachinetools.com so we can redeem your $100 OSG tap voucher. So thank you all so much. Thank you, TA, for being an absolute gangster today behind the table. You're a true expert and we appreciate your passion and knowledge. Also, huge shout out to our friends at CNC Cookbook. Make sure you check them out for some amazing content based on some industry related topics. So we appreciate each and every one of you. Make sure before you leave, you hit that subscribe button, you hit the bell to turn on those notifications so we can keep you in the loop with all the amazing content. And last but certainly not least, as always, give us a huge thumbs up. You all stay awesome, stay flexing, and we will see you next time.